Together we make Team Radian. Okay, so today we're going to talk to you about a particular type of quadrilateral called a parallelogram. I have the definition written here on the board if you want to write it down. So, a parallelogram is a quadrilateral such as A, B, C, D, which has, remember, a quadrilateral has 4 sides. And a parallelogram is a quadrilateral such that side AB is parallel to DC and AD is parallel to BC. In other words, for a parallelogram, the opposite sides of it are parallel to each other. Okay, so today we're going to go over 4 basic facts that you need to know about parallelograms in order to solve harder problems in the future. But before we do that, I'd like to give you a couple of reminders of some things that we will use in the proofs of our facts. Okay, so over here, suppose we start out with 2 lines, A and B, which are parallel to each other. We can label each of the angles, 1 through 8, and we know that angle 4 is equal to angle 6, and angle 3 is equal to angle 5. And that these pairs of angles are equal because they are alternate interior angles. Another important fact that we'll use today is the parallel postulate, which says if we have angle 1 equals to angle 7, or angle 2 equals to angle 8, angle 3 equals to angle 5, or angle 4 equals to angle 6, we know that these lines A and B have to be parallel to each other. Okay, Brady is going to go over a couple more reminders that you'll need to know for today's fun facts.
Alright, I just remind you about congruent triangle. If you have 2 triangles are congruent, that means like you have 3 sides of the triangle equally, and also like 3 angles of those triangles are equal too. So, but we want to show 2 triangles are congruent. We have 4 ways: side, 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 or side, angle, or angle, side, angle, or side, angle, angle. What does it mean? Like side, 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 we have to show 3 sides of the triangle are equally. And also side, angle, side, like CB equal to ZY, and angle C equal angle Z, and AC equal XZ. That go together. Or angle, side, angle. That means like angle C equal angle Z, and CA equal XZ, and angle A equal angle X. Or you have another way to do like angle A and side AB, or angle B, or angle B and the side BC and angle C. And the last thing, that's side, angle, angle. For example, we have BC equal ZY, and angle C equal angle Z, and angle A equal angle X. That means like the triangle A, B, and C congruent to triangle X, Y, and Z. And the last thing is bisected into 2 equal parts. Like for example, if I have the line BC and AX bisect of BC, that means BX equal XC. Alright, so now and we'll show you the fact number 1.
Okay, guys. Fact number 1 for today is that opposite sides of a parallelogram are also equal. So, starting out with proving this fact, all that we know for sure is that we're working with a parallelogram, and we want to show that the opposite sides are equal. So, we are given using this arbitrary parallelogram over here, we know that AB is parallel to CD and AD is parallel to BC. By the way, this funny symbol is a shorthand version for parallel. I'll be writing that over and over again today. Okay, so we're given this fact that the opposite sides are parallel, and in order to prove fact number 1, we want to show that side AB equals CD and AD equals BC. Then we know that the opposite sides are equal. So to do this, I'm going to add something to our picture here. I'm going to connect the line DB. Now, we know from the fact that I reminded you of earlier about alternate interior angles that this angle, angle ADBD, is going to be equal to angle BDC. And similarly, that angle DBC will equal angle BDA. So these two angles are also equal. And this is a result of the alternate interior angles. Now, we use one more fact, that DB equals itself. And from these 3 facts, we know that triangle DAB which is this triangle here, and triangle BCD this triangle are congruent. And this is a symbol for congruence. We know that these 2 triangles are congruent because they have 2 common angles and a common side in between the angle. So, this is true by angle, side, angle, which Rady went over with you earlier. Now, as a result of these 2 triangles being congruent, we know that their corresponding sides are also congruent. Therefore, AB equals CD and AD equals BC. Thus, we know that the opposite sides of a parallelogram are equal. Okay, that was fact number 1, which Rady has added to the left side of the board. Thank you.
You're welcome.
Gonna add our arbitrary parallelogram again so we can use it. The next fact root. Okay. So, fact number 2. We have in a quadrilateral A, B, C, D, that we have AB equals CD. So AB is equal to CD. When I add this dash like this, it means that those two are equal. And let's suppose that AD equals BC. Then, given this situation, we know that ABCD is a parallelogram. So once we prove this fact, we'll know not only that in a parallelogram, the opposite sides are equal, but also if you have a quadrilateral where the opposite sides are equal, it automatically has to be a parallelogram. Okay. I'm going to erase this fact so that I have more room to write, but you can find it on the board over there. All right. So for this problem, we are given just that AB equals CD and AD equals BC. And we want to show that ABCD is a parallelogram. So in other words, we need to show, based on our definition above, that AB is parallel to CD and AC is parallel to BD. Okay, so again, I'm going to add a line to our picture. AC. Now, if we examine triangle ADC and triangle ABC, we have AC is equal to itself, of course, and we were given AB equals DC and AD equals BC. So we have that this side equals itself, this side equals this side, and this side equals this side. Thus, we can use side, side, side for congruent triangles to show that triangle ADC is congruent to triangle ABC by side, side, side. Okay, so now that we know that these triangles are congruent to each other, we have that angle ACD is equal to angle CAB because they're corresponding angles. Now, since these two angles are equal, we know that line AB is parallel to DC by the parallel postulate that we went over before. And so we have AB is parallel to DC. And we can go through this process again to similarly show that we also have AD is parallel to BC. So since AB is parallel to DC and AD is parallel to BC, we know that ABCD is a parallelogram. Awesome.
Very good job.
Oh, thank you. Okay. So, now, fact 3, which you can see over here, is that in a quadrilateral ABCD, suppose that we have, I'll erase the work from before. Suppose at this time we have AB is equal to DC, and in addition, AB is also parallel to CD. Then using these facts, we want to show that ABCD is a parallelogram. Okay, so let's go over what we were given. We're given that AB equals CD, and AB is also parallel to CD. So, we can do this proof 2 different ways. One, by following the definition, where we'd need to show that that AD is parallel to BC. So then we'd have both of the opposite sides are parallel, and we'd be done, and we'd know that this quadrilateral was a parallelogram based on the definition. But if we don't want to do it that way, which is the proof by definition, we can also show that AD equals BC. And then, since we have AB equals CD and AD equals BC, we know from fact 2, which we proved before, that the quadrilateral is a parallelogram. Okay, so let's start off this proof. And I'll show it both ways. Okay, so again, I'm going to add the line AC. Now, since AB is parallel to DC, then by our alternate interior angles theorem, we have that angle BAC is equal to angle ACD. So angle BAC equals angle ACD. That was by alternate interior angles. Thus, for triangle ABC and triangle ADC, we have that AB equals CD, because that was given, and we just showed by alternate interior angles that angle BAC equals angle ACD. And we also know that AC equals itself. So using these 3 facts, we know that triangle ABC and triangle ADC are congruent. So I'll add our symbol for congruent. And this is by side, angle, side. because we have AB equals CD. These angles are equal, and then AC equals itself. Okay. Thus, since these two triangles are congruent, we know by corresponding sides that AD has to be equal to BC. Thus, we now have that AD equals BC and AB equals CD. So, by fact 2, we know that AB, CD is a parallelogram. Now, alternatively, we know by corresponding angles, using the same two triangles as before, triangles ABC and ADC, we have that the corresponding angles DAC and BCA are equal. Thus, using the parallel postulate that we went over earlier, this condition implies that AD is parallel to BC. And now we have that both of the opposite sides are parallel. So again, we know that ABCD is a parallelogram according to the definition. Okay. You guys following along so far are doing great. Now, Brady is going to go over our last fact for the day, which is a little bit more complex than the 3 facts we just did, but y'all guys can handle it.
Right. What is the fact number 4? On quadrilateral is a parallelogram if and only if its diagonal bisect its order. I want to point out if and only if. That means we have to show it 2 ways, like that. But what we have from this fact, like we have the given A, B, C, D, A parallel line, and we need to show before we show, I want to draw a picture for you. For example, A, B, C, and D. Thank you. What did we know from the definition and fact 1, fact 2, and fact 3? If we have A, B, C, D, E a parallelogram, that means AB parallel to BC and AD parallel to BC, and also like we have AB equal DC and AD equal BC. Now we have to show AC bisect to BD. And I call the intersection here that x. That means we have to show dx equal bx and ax equal xc. We have to show dx equal bx and cx equal ax. So how can we do it? If we know, like, first thing, AD equal BC, because ABCD is parallelogram. And whatever we know about the parallelogram, AD also parallel to BC, so we have the angle DAC equal to the angle AC and B. And also we have this angle CBD equal to the angle BD and A. So far we have AD equal BC, that given, and angle BCA equal to angle DAC and angle CED equal to the angle BEA. So we have the triangle CBX congruent to the triangle A D and X. So from here we can see Vx equal to dx and Cx equal to Ax. That corresponding size. And now we have to show if the given dx equal bx and ax equal cx, we have to show ABCD is parallelogram. Sorry. So now we have dx equal bx and cx equal ax. We have to show A, B, C, D, E parallel. And now we have many ways to do it. Like we can show AD equal BC and AD equal DC, or we can show AD equal BC, then AD parallel to DC, or another way like AB equal DC and AB parallel to DC. But first thing what we have from now we have dx equal bx and ax equal cx right here. So I will show two triangles B BXC congruent to triangle ADX. So what we have, BX equal DX, that given, and CX equal AX given, and we have this angle AX and D equal to angle CX and B.
And those two angles are equal because they're vertical angles.
Right, that vertical. So triangle BXC congruent to triangle BX and A. So from here we have AD equal BC, that corresponding sine. And then we have angle DAX equal to angle BCX. 1, 2, right. BCX, this angle equal to this angle. So we have AD parallel to BC. So from fact number 3, we have AD equal BC and AD parallel to BC. So ABCD is parallel ABCD parallel. All right.
Okay. So that was 4 basic facts that you need to know about parallelograms in order to solve more complicated problems in the future. You guys feel ready for that? I hope so. And before we go, Rady is going to treat us with making a connection between fact number 1, which was that opposite sides of a parallelogram are equal. He's going to connect this concept to algebra by providing you with an algebraic proof as opposed to the geometrical proof that I gave you earlier. Okay, take it away, Rady.
All right. Now I have 4 lines. Line number 1 is y equal x plus 1. Line number 2 equal y equal x plus 4. Line number 3, y equal minus x plus 1, and line number 4, y equal minus x plus 5. First, I have to draw the line number 1 first. From line number 1, if x equals 0, y equal 1, x equals 0, or y equal 1, right here, and x equal minus 1, y equals 0, x equal minus 1, y equals 0, so I have first line, have through 2 points, and mark it line number 1. And for line number 2, similarly, we have x equal 4, x equals 0, y equal 4, x equals 0, y equal 4, 1, 2, 3, and 4. And x equal minus 4, y equals 0, minus 1, minus 2, 3, and 4. Now we have line number 2. And as we know, line number 1 will parallel to line number 2 because we have the same slope. And now we plug in line number 3, x equals 0, y equal 1 is point, and x equal 1, y equals 0 is point. So I have this line. And line number 4, x equals 0, y equals 5. X equal minus, x equal 5, y equals 0. 1, 2, 3, 4, and 5.
For these two lines, the slope is -1. So again, since they have the same slope, they're not going to intersect, so they're parallel.
Yes. So now we have so far line number 3 parallel to line number 4 and line number 1 parallel to line number 2. And I call the intersection of line number 1 and line number 4 that A with XA and YA. And the intersection of line 2 and line 4 that is B with XB, YB. And C, line number 2 and line number 3 at CYC. And right here D, XD, YD. Now my goal will find A, B, C, and D. Then that's step number 1, and step number 2, I will check AB equal AB equal to CD or and AC equal BD equal now. So that's my goal.
By the way, guys, just to point out, if y'all haven't noticed it by now, here, mapped on the coordinate plane, these 4 lines, we have, oh, I got it, thank you. This parallelogram, ABCD. Awesome, huh?
Oh.
And Rady's about to prove that we have a parallelogram, correct,
Alright.
Rady?
Thank you. Yeah, ready. Okay, as we know, point A belongs to line number 1 and line number 4, right? A belong to line number 1 and A belong to line number 4. So what will we have from this? So we have just plug in XA and YA to equation of line 1 and line 4. So we have So I will mark this equation 1 and equation 2. If I add 1 and 2, what will we have? So YA plus YA equal to YA. XA minus XA equals 0. 1 plus 5 equals 6. And I keep the equation 1 for me to use it later. So from here we have, I will move this equation to down here. So YA, we have YA equal 3 because 6, we will divide both sides for 2 and we have YA equal 3. And plug in YA equal 3 here, we have XA equal 2. So we have point A with X equal 2 and Y equal 3. And similarly, we will figure out like point B will belong to line 2 and B will belong to line 4. And just plug in and do it the same thing. I think like you can do it. So I have the solution here would be equal 1/2 and 9/2. And then we have C equal minus 3/2 and 5/2. And D equal D 0, 1. So that's we have so far. And then now my goal will check AB equals CD or not. And we have the formula for the length of AB. I just remind you equal square root of XA minus XB square plus YA minus YB square. Or you can write down like XB minus XA square plus YB minus YA square. It doesn't matter because like you have square, so.
That's true.
Alright.
And we call that normally the distance formula.
Yes, right, I forgot. Distance. Alright, so we just plug in XA and XB, YA and YB. We have AB will equal to square root of 2 minus 1/2 square plus 3 minus 9/2 square. And we have square root of 4 minus 1 equal 3, 3 square equal 9, and 2 square equal 4, plus, by the same thing, 2 times 3 equals 6, 6 minus 3 equal minus 3, square equal 9 over 4. So we have square root of 18 over 4. And do the same thing for CD. We will have xd equals 0. So plus 5 half minus 1 square. And the same thing, we have square root of 9 over 4 plus 2 times 1 equal 2, 5 minus 2 equal 3 square equal 9, and 2 square equal 4. So we have square root of 18 over 4. Okay, I won't repeat it. And then we will have AC equal BD equals square root of 50 over 4. We just do plug in the same thing like we do so far, and like we will have this solution. Alright.
Thus, we have at the opposite sides for this parallelogram, ABCD, which is drawn in the coordinate plane using these 4 lines. The opposite sides, he just proved, are equal.
Awesome.
Okay, well, now you know everything you need to know about parallelograms in order to start trying out some tougher problems. Thank you for watching, and good luck to all of you.
Alright.
Bye.
Bye.